Hi everyone, welcome back to your course, Chemistry for Engineers Laboratory. Today our topic is about experiment number 4, mechanical properties of your materials. This is your instructor, Engineer Janaika A. Tapiador. So the title of your experiment is Mechanical Properties of Material. However, I haven't found any virtual lab that can actually fully equip you with the things that you need to know in order for us or the experiment. I can't find any experiment that would suffice the things that you need to know regarding the mechanical properties of your materials. So for today, I would just be providing you the theory behind the mechanical properties of your materials, which will be very helpful in your higher engineering subjects. So it says here, at the end of this experiment, the students shall be able to observe and evaluate the mechanical properties of your material. And for the topics, these are the topics. You have your introduction, followed by what is stress, strain, Young modulus of elasticity, how to understand your stress-strain diagram, and of course, mechanical properties of your materials. So as an introduction, we will be dealing with mild steel, since this is the most common material that is being used in the construction industry. So what is mild steel? Mild steel is a type of carbon steel with low amount of carbon. It is actually known as your low carbon steel, although ranges vary depending on the source. The amount of carbon typically found in your mild steel is about 0.05% to 0.25% by weight. So your steel is actually made up of iron with the addition of carbon. So iron plus carbon, and then you combine it together. That's the term we call your alloying, will provide your steel alloy. And if the carbon content is just around this range, we call it your mild steel. So it says here, when the steel is curved, it is important to keep the stress-strain curve ratio for mild steel in mind. So this figure, the figure on the left, is a stress-strain graph that reviews all or that reviews the properties of steel in detail. So whenever you subject your steel whenever you subject a force into your steel, might that be your compression force or your tension force, of course there are changes that will happen. So this is what we call your stress-strain diagram, which shows you the possible things that will happen, or the thing that will happen when you subject your steel in a load. So you have the stress here. So on your y-axis is the stress and the x-axis is the strain. Although I will be focusing on this more in the later part of the introduction, let me just provide you first a very short background on what is stress and what is strain, so that you could fully understand this particular graph. So what is stress? If an applied force causes a change in the dimension of the material, then the material is in the state of stress. If we divide the applied force by the cross-sectional area, we get the stress. So meaning the stress that the material experiences is due to the force that you are applying, such that this is the symbol for stress. This is the small letter sigma, is equal to F here will stand for the force, and of course A is the cross-sectional area of the material. The symbol for stress is the Greek letter sigma, If the force is tensile or the force applied is tensile, then you will obtain a positive stress. And if the stress that you calculated is a negative one, then it means that it is a compressive stress. So when we say tensile stress, it is simply the stretching of the material. So for example, you have a rod, tapos pupull mo siya apart, or you're gonna try to pull it apart, then that is for your tensile force. And another material for your compressive is, as the term implies, you are gonna compress the material. So pag kinompress mo yan, meaning you're applying compressive force, and when you are trying then to pull it apart, you are applying your tensile force. And the standard international unit of stress is in terms of Pascal, where 1 Pascal is simply equal to your 1 Newton per meter squared. Kasi nga, diba, force, which is in Newton, and of course, the area is in square of the length, so meter squared. Yeah, force over area. So the formula to derive the stress number is, I already introduced this, your sigma is equal to force all over area. So let's try to solve a sample problem regarding stress. So it says here, a steel tube with a diameter of 100 millimeters must carry a tensile load of 400 kilonewtons. You are to determine the stress under the load in terms of Pascal. So following your GRS method, you're given the diameter, which is 100 millimeters. And of course, the force, which is 400 kilonewtons. And of course, the required is the stress, which is the symbol sigma. So your solution is, of course, we first write the main equation. That's your stress is equal to force all over area. And you know that your area of a circle, since the cross-section of the tube, kasi sabi diba tube, so it's a cylinder, and the area of the circle, kasi yun yung cross-section ng cylinder, is pi r squared. Substituting all of the values that we have, you will be given here. Diba? The force is 100 kilonewtons, and of course you have to convert that into newtons. So, knowing that 1,000 Newton is equivalent to 1 kilonewton, and in the denominator you have pi multiplied by the radius squared. Now, you have to understand that what you were given is the diameter. And of course, you already know that the diameter is twice the radius. Therefore, the radius is half the diameter, kaya po 50 yung nakalagay dito. 50 millimeters, and of course, you have to convert that into meter, knowing that 1 meter comprises of 1,000 millimeters. And of course, very important, you have to square the radius, such that you will be given, or you can calculate the final answer equal to, that's around 12,732,395.45 pascals. Or if we convert that into your megapascal, that will be 12.7324. So that's how you calculate the stress. It's very simple. Now, how about your strain? What is strain? Strain is the change in length, or rather the change in the dimension with respect to the original length. So for example, this is your rod or tube, and if you apply compressive force, it will follow that. Of course, diba, may stretch yung material, such that after the final force is released, there will be a change in length. Diba, syempre hahaba siya. So we account for that change in length such that when we calculate your strain, it's simply the change in length all over the original length. Or you have the formula here. This is a Greek letter, your epsilon. So epsilon is simply equal to your strain, which is equal to your change in length. Of course, that will be the new length minus the original length all over the original length. So that's how you calculate your strain. So let's have a sample problem. What is the strain in the previous problem if the original length is 298 millimeters and the resulting deformation due to the force is 15 millimeters? So you are given an original length which is 298 millimeters and of course the change in length which is 15 millimeters. Sometimes the change in length is denoted by this symbol. This is also what we call your elongation. Okay? Yung symbol na yan. And of course, you are required to calculate for your strain, which is represented by the Greek letter epsilon. So what is strain? Of course, we write your equation first. So that will be the strain is equal to the change in length all over the original length. And we substitute whatever we have. So that will be 15 millimeters divided by 298 millimeters, giving you a value of strain equal to 0.0503. Now, one thing you have to remember, your strain is unitless. So it doesn't have any units since it is a ratio of lengths. Okay, so 0.0503. So next topic is your Young's modulus, or it's usually denoted by this symbol, your E. Young's modulus, or what we call your elastic modulus or tensile modulus, is the measurement of mechanical properties of linear elastic solids like your rods, wires, etc. Young's modulus describes the relationship between your stress and your strain when a certain object is undergoing deformation. The Young's modulus is named after the British scientist Mr. Thomas Young. So it's simply the relationship of your stress from that of your strain. How do we calculate your Young's modulus of elasticity or Young's modulus? So, diba, it's simply a ratio of your stress over your strain. Yun po yung Young's modulus. So, madali lang siya. Direct substitution lang siya. Or that will be equal to force all over area, all over your delta L, all over your change in length. So, let's go now to your stress-strain diagram. So this is just another stress-strain diagram similar to the one that I actually showed earlier. So you have here your stress, diba, dito sa y-axis, and of course the strain is in the z-axis. If mapapansin nyo, you have certain points there, your P, E, Y, U, and F, which will actually explain the stresses and the strains that a certain material undergoes. Now, one thing that you have also to remember, class, is that every material has its own stress and strain diagram. For this one, this is steel, okay? So it says here, the relationship between stress and strain in a material is determined by subjecting the material specimen to a tension or compression test. In this test, a steadily increasing axial force is applied to a test specimen and the deflection is measured as the load is increased. Kumbaga parang, diba, ganito kasi yan sa ginagawa sa universal testing machine. So you have a specimen, usually it's a rod. Tapos, ang ginagawa usually dyan is tension. So, yung, kumbaga, you're trying then to pull the material apart, ganyan. Tapos, yung, may load, yung specific force na nagpupull dun sa material apart, pataas siya ng pataas. Hanggang sa umabot dun sa point na mag-break na yung material. Now, once na nag-break na yung material or nag-rupture na yan, the UTM or the Universal Testing Machine will actually show you the stress-strain diagram. So, for steel, ito yung kanyang stress-strain diagram. Tapos, we have to make sure that we understand this particular letters that is indicated here para makapag-interpret po tayo ng iba't ibang klase ng materials in your higher engineering courses. So, the very first one is your letter P. So, ito po siya, letter P. When you see this letter P or when you see that particular point, this is called your proportionality limit, which represents the maximum value of stress at which the stress-strain curve is linear. So if you take a look, mula dito sa 0, meaning walang stress and walang strain, paakyat siya ng paakyat in a linear form. So parang straight line lang siya. Tapos, pagdating po dun sa letter P na yan, that's actually the end of the linear curve. Kasi if you try to take a look now, di ba, pagdating dun, medyo nag-curve na siya ng konti from your letter P to your letter E. So, yung letter P, that's actually what we call your proportionality limit. Kasi po, yun lang po yung point kung saan yung stress mo tsaka yung strain mo are proportional to each other. So, next is your letter E. So, yun naman tayo kay letter E. We call this your elastic limit. So, what is the elastic limit? It says here, it represents the maximum value of stress at which there is no permanent set. Even though the curve is not linear between the proportionality limit and the plastic limit, the material is still elastic in this region. And if the load is removed at or below this point, the specimen will return to its original length. So, ito po yung elastic limit. Ibig sabihin po, hanggang dyan sa point na yan, di ba, dito nga po yung proportionality limit. Tapos medyo nag-curve na siya dito ng konti. So, medyo curve na po yung distance between your P and E. The E or your elastic limit states that yung material mo, pag nirelease yung load, yung material mo is kaya niya pang bumalik sa kanyang original shape without any deformation or without any fracture for that matter. So, you have your proportionality limit, end of the linearity. You have your elastic limit. It's the maximum value that the material can handle na babalik pa siya doon sa kanyang original shape or original length. So, next now is your Y. This is what we call your yield point. Ayun po siya, yield. So, the yield point represents the value of stress above which the strain will begin to increase rapidly. The stress at the yield point is called your yield strength. So, ibig sabihin po, pagdating po dito sa part na to, mabilis na pong mag-i-strain yung ating material. Ibig sabihin, medyo mabilis na yung pag-change ng or pag-change ng length ng material. So, kumbaga pag sa tension, medyo mabilis na yung paglaki ng change in length. Parang ganun po. And that's what you call your yield strength. Diyan po yun mag-start. So, kaya 'di ba pag nakikita nyo dito, medyo yung stress kasi natin nakabase yan sa force. So, 'di ba konting force lang yung aangat mo, pero yung strain niya or yung change in length niya medyo lumalaki. Konting force lang, pero medyo malaki na yung nagbago dun sa strain. So, 'di ba? Sabi niya lang dito, which represents the value at which the value of stress above which the strain will begin to increase rapidly. So, kumbaga hindi na proportion yung inyong stress and strain. Kumbaga dito, konting stress na lang in-apply mo, pero sobrang laki na nung pinagbago nung strain ng material. So, ayan po. Your letter Y. Diyan po siya mag-start. And of course, you have your letter U. So, your letter U corresponds to the ultimate strength. Now, when we say ultimate strength, that is the maximum value of stress that the material can handle. So, the ultimate strength is also referred to as your tensile strength. So, it says here, after reaching the ultimate stress, specimens of ductile materials will exhibit necking, in which the cross-sectional area in a localized region of the specimen reduces significantly. Diba, syempre, pag in-stretch mo po yung material, just like in a rubber band, diba may part dun na pag ini-stretch mo yung rubber band, meron siyang certain point kung saan para siyang nagtitear, kumbaga parang doon na siya napupunit. So parang doon po mag-start yung what we call your necking. Kumbaga numinipis na po yung material mo before talaga siya mag-break. So your ultimate strength, diba, it's the maximum value of stress on the stress-strain diagram. Yun po, yung ultimate strength niya. And finally, your letter F, this represents your fracture point or the break point at which the material falls into two pieces or breaks into two pieces. So, for every material, meron po siyang ganito. Meron siyang proportionality limit, elastic limit, your yield point, your ultimate strength, and of course, your fracture. So, ganun lang naman po ma-interpret ang stress-strain diagram. This is very important, especially for your higher engineering subjects. Kasi you have to be able then to identify kung gaano kabigat yung force na kayang i-withstand ng isang material, especially when you're already designing construction buildings, etc. So, importante po itong stress-strain diagram. And then again, every material has its own stress and strain diagram. And I represented you the stress-strain diagram of mild steel. So let's go to the last topic, your mechanical properties of material. So it says here, the mechanical properties of material are those which affect the mechanical strength and ability of a material to be molded into suitable shapes. Some of the typical mechanical properties of a material include the following. You have your strength, toughness, hardness, hardenability, brittleness, malleability, ductility, crip and slip, resilience, and fatigue. So, ito pong mga to, para lang siyang, itong mechanical properties of materials, dito po yung mga terms that we have to be familiar with in order for us to assess kung ano ba dapat yung material na gagamitin natin when we try then to construct something. Although I will just be providing you here a simple definition of each, and in your higher subjects or your higher courses, dyan na po i-calculate nyo po yung mga yan. Okay? So first, let's go to strength. It says here, strength is the property of material which opposes the deformation or breakdown of material in presence of external forces or load. So, kung gaano lang siya di ba, ano ba Tagalog ng strength? Anyway, I'm not very good with Tagalog, but this is the definition. So, opposes the deformation of or breakdown of a material. And then you have the toughness. It is the ability of a material to absorb the energy and gets plastically deformed without fracturing. A very good example of a tough material are your stainless or your spring, di ba? Parang, kumbaga, nade-deform siya, pero at the same time, pag nilalagyan mo ng load, di ba? Nade-deform yan kasi nagko-compress yan. However, when you try then to pag nirelease mo na yung load, di ba wala ka naman, pag kaya niya pa, wala ka naman makikita ang mga fracture doon sa spring. So, it's actually, your toughness have a relationship with your strength and your ductility. So, next is your hardness. Now, when we say hardness, it is the ability of a material to resist permanent change in shape due to external stress. So, meron po tayo iba't ibang various measurement of your hardness, such as your scratch test, may mga ganun po yan, which you will be dealing on later, which you will be dealing when you go to your higher engineering courses. But just the trivia, your hardest material is actually your diamond. Naka-base siya sa Mohs scale of hardness. Next is your hardenability. Now, it is the ability of a material to attain the hardness by heat treatment processing. Now, may mga material kasi tayo na, kumbaga, nagiging hard siya pag pinapainit mo na, diba? Pag you are treating that particular material using heat, kumbaga, mas nagko-compact yung mga atoms and the material eventually becomes hard. So, that's your hardenability. Brittleness. So when we say brittleness, it indicates how easily a material gets fractured when it is subjected to a force or load. Kumbaga yung parang konting smash mo lang, ganyan, sa isang bagay, nagiging brittle na siya. Example is your glass, di ba? Parang, if you try to apply enough load, magbe-break siya kaagad. So, your glass is actually brittle. So, malleability, I already introduced this during your lecture proper. Now, it's simply the ability of a material to be hammered into very thin sheets, just like your aluminum foil. But here's kumbaga ito yung definition niya in terms of materials. Malleability is a property of solid materials which indicates that how easily a material gets deformed under compressive stresses. Of course, you also have your ductility. Now, ductility is often categorized by the ability of the material to get stretched into a wire by pulling or drawing. So, kung gaano siya kadaling i-draw into wires. And in terms of material, ductility is a property of a solid material that indicates how easily a material gets deformed under tensile stress. Kumbaga, pag sa malleability, it's under compressive stress. Thus, sa ductility, it's under tensile stress. And you also have your crip and slip. When we say crip, it is the property of a material that indicates the tendency to move slowly and deform permanently under the influence of external mechanical stress. It results due to long time exposure to large external mechanical stress within limit of yielding. Kumbaga pag paulit-ulit, diba, for example, this belt here, paulit-ulit lang naman siya mag-roll, diba? Pero over time, magkakaroon na po siya ng mga creeps kasi syempre, diba, paikot-ikot lang siya, ganyan. So, there will be creeps and slips in these materials over time. So, when we say slip naman in a material, slip in material is a plane with high density of atoms. Usually, your creep and slip, they go together. Para siyang tinatawag din minsan na mechanical wearing, especially sa mga conveyor belts, just like this one. Resilience. Okay. Resilience is the ability of material to absorb the energy when it is deformed elastically by applying stress and release the energy when stress is removed. Proof resilience is defined as the maximum energy that can be absorbed without permanent deformation. Kumbaga, it's kapag i-relate natin sa stress and strain diagram, para siyang yung elastic limit natin. Kasi diba, pag sinabi niya dito, proof resilience is defined as the maximum energy that can be absorbed without permanent deformation. And lastly is your fatigue. When we say fatigue, this is the weakening of material caused by repeated loading of material. When a material is subjected to cyclic loading and loading greater than certain threshold value but much below the strength of the material. Diba, usually ito nangyayari siya sa mga piston cylinders, especially sa mga cars, diba, pag yung piston cylinder, pag ganun siya ng pag ganun. So, repeated kasi siya, kumbaga repeated yung force na na-apply mo. So, over time, syempre, yung material, nagkakaroon na siya ng fatigue. So, yun lang naman. Very simple. Tawag dito. Just a very short introduction of the terminologies that you need to know in preparation for your higher engineering courses. So that's it for your mechanical properties of materials. Please start doing the activity in your assignments tab. I believe that will be your activity number 3. So that will consist of 4 problems that you would need to answer. And as it was before, you have to make sure to answer in a bond paper following the format I provided you and answer 1 problem per page. So thank you so much for listening, class. Please don't forget to click and subscribe. And of course, as I always say, stay home, stay healthy, and stay safe. Goodbye, everyone.